So let's talk a little bit about decimal operations. This should be 100% review. We're not really learning how to do decimal operations in 6th grade, so this is just something to make sure that you still remember how to do decimal operations from the past. So I'm going to take a couple of the problems from your quiz that you just took to talk about those. So if I had a addition problem to start with, because that is probably the easiest for us, 15 and 12 hundredths plus 36 and 54 hundredths. So the most important thing when I'm adding or subtracting decimals is that I'm lining up those decimals, that they are 100% in line. So if, for instance, I had just 15.1 and not 15.12, then I would still want to line those up. And it can be helpful just to add a 0 so that you know that it's a placeholder and that it's not going to throw you off. Because I could add any amount of zeros onto the end of this that I wanted to. So for now, though, I have 15 and 12 hundredths and 36 and 54 hundredths. So I'm going to add up my pieces. 4 plus 2 is 6. 5 plus 1 is 6. I can move on. 6 plus 5 is 11. So I'll put my 1 for the ones place, and then I'm going to carry my 10, because 11 is made up of 10 ones, and 11 is made up of 11 ones, which is the same as one group of 10 and 1 1. So I carry my 1, and then I have 1 plus 1 plus 1, 2, 3 equals 5. So I have 51 and 66 hundredths. I can easily check this by rounding. So if I have, this, I could just think, 15, and then round up my 36 to 40, and I would think, okay, so my answer should be something like 55. I rounded up, so that's going to be a little bit high. So 51 is a good estimate. If I were subtracting, so let me go ahead and do one of those subtracting problems, it's pretty much the same thing. I highly recommend that for decimal problems that you're doing by hand, that you either turn a sheet of paper sideways so that you can see the lines, going vertically, and you can line up your numbers in each of those columns. It's really helpful. Or you could use graph paper and just have each number in a little square of the graph paper. That can also keep you on track. So for adding and subtracting, multiplying and dividing decimals, it's very, very helpful to do that, to keep all of your place values lined up. So let me go ahead and do 75 and 58 hundredths minus 20 and 81 hundredths. So I have 8 minus 1 equals 7. I'm trying to take 8 away from 5. That doesn't work, so I'm going to go to the next number over to regroup. So I'm going to take away one set of my ones and make that 10 tenths. So now I have 10 tenths. So this number becomes like 10 plus 5. It becomes 15 essentially, because I now am taking this group of this 1 and making a group of tenths out of it. So I know that 10 over 10 is equal to 1, so 10 tenths is equal to 1, so I'm moving that this 1 to become 10 tenths. 15 minus 8 is 7. 4 minus 0 is 4. 7 minus 2 is 5. This works for me. If I were to say, 75 rounds to 80 minus 20 equals 60, I round it up, so that's going to be a little bit of a higher number, which it is. Okay, so but 80 and 54 60 and 8 and 54 are pretty close. So it's still a good estimate. The next number I have is a division problem. So I'll do 8 and 97/100ths divided by 3. So if I'm doing long division my typical way, then I put a 3 into 8 works 2 times, because 3 times 2 equals 6, and I have 2 left over. I bring everything else down. Now I'm thinking about, okay, so can 3 go into 29? Three times 9 is 27. I have 2 left over. I bring down my 7. 3 goes into 27 9 times. 27. 0. So I can just follow my long division procedure to do that. Oh, I forgot to show you my estimate. So my estimate would be, it should be close to 3, which it was, because 8.97 is close to 9, divided by 3 would be 3. So I can check my answer that way too, that it makes sense. So even if you weren't sure about the long division stuff, and you could still make a solid estimate and look for, if you had a multiple choice option, then you could look for which number is close to 3. That would make sense. Okay, so your answers, whenever you're guessing, your guesses should always make sense. Alright, lastly, let's look at an example of multiplication. So 0.03, also known as 3/100ths, times 1 and 1/10. Notice that I do not have my decimals lined up for this, so I don't need to. I don't need to have my decimals lined up to multiply decimals. So I can follow my procedure to think of multiplying. So I multiply this first part to each of the subsequent parts. So 1 times 3 is 3, 1 times 0 is 0, 1 times 0 is 0. I put a 0 as a placeholder because right now I'm multiplying this one, so it's like I'm multiplying by this extra 0 space. So each time I would need to move that power of 10 over. So 1 times 3, 3, 1 times 0, 0, 1 times 0, 0. Now I add up the pieces. I'm just going to put 1 0, still doesn't matter that much. 2, 3,